Hello everyone, welcome to this video tutorial about writing systems of equations. Yesterday we just graphed them, but now let's talk about how do you actually get two equations that are related to each other. Yeah, you could graph two equations, but why do we even have those two equations in the first place? That's what today's lesson is. If you don't know, go ahead and write down that a system of equations is a set of equations with the same variables. Each equation expresses a relationship between the variables. When you do that, that places constraints or restrictions on the values that the variables represent. Write that down in your journal if you don't know that. You probably don't know that, so go ahead and write that down. Constraints and the definition that goes with it. Real-world situations often require that there be additional constraints on possible values of variables. This means in real life, there are variables, but those variables can't just be any number like we can have on a graph. A graph can have any number, infinite numbers. But in real life, there's a limit to how big things can be. Let's go ahead and do example number 1 to see if there are any limits in this story. At a movie theater, an adult ticket costs more than a child's ticket. Let X represent the cost for one adult ticket and Y represent the cost for one child's ticket. Then, so this is just a story. That's the setup. We're going to the movies. X is going to be for adult tickets. Y is going to be the cost for child's tickets. And we already know that an adult ticket costs more than a child's ticket. List the constraints on the variables using equations. Describe the kinds of numbers that could be used for X and Y in this situation. Explain the reason for these constraints. I'll go ahead and work with you for this. The constraints are the limits. So we know, and we're going to use the variables. So this is X and Y. The very first sentence says that adult tickets cost more than child tickets. So we know that X is going to have to be greater than Y. It says, describe the kinds of numbers that could be used for X and Y. Well, if X has to be greater than Y, and we're going to the movies, maybe an adult ticket costs $8 and the child's ticket costs $5. That could be it. Explain the reasons for these constraints. The problem says adult tickets cost more. And something that we haven't done yet is we haven't actually defined. You need to define the variables. X represents one adult ticket. X is equal to one adult ticket. But I accidentally skipped the word cost. So one adult ticket's price. I'll word that better whenever I do Y. Y is equal to, we need to define this variable, so you have to write this down. If we're using X's and Y's right here on the left, then we have to say what those actually represent. Y is equal to the cost for one child ticket. Now let's do part B. Amy purchased 2 adult tickets and 3 child's tickets and spent $34. Heidi purchased 1 adult ticket and 2 child's tickets and spent $20. Write an equation for the total cost of movie tickets for 2 adults and 3 children. 2 adults, 3 children. Sounds familiar? Let's go back to the first sentence. 2 adults, 3 children. If only there was a way to shorten the number 2. Okay, we did that. Now, if there's a way to shorten the word adult tickets, is there anything that has to do with adult tickets? It's X. So we're going to put X. 2 times X. We're just trying to shorten the story by using math variables. 2 times X is 2 adult tickets. 3 child's tickets is going to be 3 times Y. You don't really have to put that dot there, but I'm putting it to be very specific. We're multiplying. But you don't just have 2X and 3Y. What does and mean in math? What's the operation that and is telling you to do? apples and oranges. That means apples plus oranges. So this is 2 adult tickets plus 3 child's tickets. And that means that they spent a total of $34. That's the equation that they want in question number 1, in part number 1. Now let's do part number 2. Write the total cost for 1 adult and 2 children. Now, my first time going through this, I forgot, but in the second sentence, they talk about 1 adult. 1 adult ticket, so that's 1, and then what's the variable we use for adults? X, plus 2 children, so 2, Y. I'm not going to put that dot anymore. How much does that equal to? Do we know? It's $20. That's what the problem said. So let's write that down. Let's move on. Part C. Mr. Who and Miss Claremont want to take their science classes to see a movie. That's nice of them. 4 teachers, aka adults, and 28 children, students, will attend at regular price. The total cost of the tickets is $100. I want you to go ahead and write this equation. You read the rest of this. You write that equation. Pause the video now. I'm going to show you the answer in just a moment. Okay, so we did the first part. These are the 2 equations you should use. I would expect you to get the first one right, no problem. But the second one, 4x plus 28 times 1/2 y, you might have written that differently, but let me show you why that's how you should write it. They said each child's ticket is half off the regular price. Each child's ticket. We used some words earlier about a child's ticket. Y is equal to 1 child's ticket. So this means 1 child ticket cost equals Y. What did they say down here in part C? Each child's ticket is half off the price of a child's ticket. So what that means is they cut this in half. They divided the left side of the equation by 2. And because they did 1/2 the price of a child's ticket, now we have to do 1/2 of Y. So that means in my equation, instead of just writing regular Y, I put 1/2 Y. Yes, this 28 and this 1/2 will distribute to make something simpler, and we'll be able to do something like that in a few days, next week. But this is the equation I have. Describe the constraints for the 2 possible costs. All right, so we already have the constraint that an adult ticket costs more than a child's ticket. But in this situation, we have another constraint. Look at how much money they're spending. They can only spend $100, and they can only spend $58. If they could only spend $100, can they buy an infinite amount of tickets, or is there a limit? If their limit is $100, then that means that the left side of the equation also has to have a limit. You can't buy more than a certain amount of adult tickets, or the adult tickets can't cost more than a certain amount, and the children's tickets also have a boundary for how much they can cost. So let's just make a boundary. What makes sense? 4 adult tickets and 28 children's tickets. What if this was 4 times... What if every child ticket was $1? How much would an adult ticket need to be? If this Y is instead $1, that's 28 times 1. How much would each one of these adult tickets need to be? Well, if we subtract 28 from 100, we'll get around 75. So then divide 75 by 4, you get less than like $17. So let's just say, just from some very quick math, the adult tickets must be less than $17. If they cost more than $17, then these equations aren't going to work out. Because if we put 17 right here in the second equation, 4 times $17, 4 times 17 is, that's like 60 something, 70 something. which is more than this 50 here. So it has to be true. We are restricted by that adult tickets must be less than $17 in their cost. The constraints are what is something that is definitely true that's limiting, because look, it's a restriction. Constraint is a restriction. So what's something that's definitely true about this problem that's placing a restriction on our possible answers? Since the cost of either ticket is greater than 0, how can you use equations you wrote in Part C to determine the constraint for the maximum cost of an adult ticket and a child's ticket? Well, I already made a restraint for the maximum on an adult ticket. It has to be less than this number. If it has to be less than this, then that means that 17 is the max. So what would be the maximum price for a child's ticket? Let's look here. We have 28y equals $100. So a child's ticket is going to be more than $3. But if we look at the bottom one, 28 times 1/2, that'd be 14, 58. Let's do 58 divided by 14, see what happens. Let's put a 4, 16, 5, 56, 2. So 4.5. Maybe a child's ticket is around $4.5. I don't know if it is or isn't. You would have to do more math to figure it out, what the exact price is, and we'll talk about what math you would have to do next week. Okay, so I want you to go down and I want you to try to do question number 1 of the practice. Go ahead and do question 1 of the practice, part A and B, based off of what we just did in example number 1. You do that, and I'll show you the answer in a bit. So pause the video. Okay, here's what I have for number 1. X is going to be the questions in round number 1. Y is going to be the questions in round number 2. My restraint that I came up with was X is greater than Y. And I'll explain that in a bit. But first let me say why X is round 1's questions. It says a game show awards 60 points for 2 rounds of questions. In the first round, each question is worth 2 points. And the second round, each question is worth 3 points. 25 questions are asked in the show. So this 25 at the bottom, that's going to make one of the equations down here in part B for the system. That's 60 points at the top. That's going to be the total for the other equation in the system. One equation, the 60 points, is all talking about points. So you got these 2-point questions, you got the 3-point questions, but what's in common between both of those rounds and both of those types of questions? The fact that they're questions. The only thing different is the point value, but what's the same is that they are questions. We need to pick a variable for X and for Y that's the same in this equation and the same in this equation. If this isn't making sense, send me a message about it.